Hey, welcome back to Max May DC with AB, where your hatred for Max actually turns into love. So, in the previous videos, we were discussing about types of set. So, if you haven't seen the first video of types of set where we discussed about empty set, singleton set, finite set, and infinite set, please check it out. The link is in the description. Now it's in the annotation, or check out my channel. So in this video, we'll be discussing about equivalent set, equal set, universal set, and disjoint set. So with no delay, let's get into the topic. So let's discuss what do you mean by an equivalent set. So when two sets have the same cardinality, those sets are said to be equivalent set. That is, given two set, those sets must have the same cardinality, and therefore those two sets are said to be equivalent. It is not necessary that those two sets, or let's consider A and B, must have the same elements. No need for that. You must have the cardinality for set A and cardinality of set B to be equal, and that's it. So consider set AB. A is equivalent to B if n of A equals n of B. Let's actually get in detailed with this example. So let us consider P to be the set of integers where it lies between -3 and 0. So it's nothing but -3, -2, -1 and 0. So these are the four elements. So the cardinality of P is 4, and the set of all prime factors of 210. So let's actually find the factors of 210 and then let's decide which are prime numbers. So 1 times 210 is 210. So 1 and 210 are factors of 210. And 2 and 105 are factors of 210. 3 times 70 is 210. 5 times 42 is 210. 6 times 35 is 210. 7 times 30 is 210. 10 times 21 is 210. And 14 times 15 is 210. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 factors for 210. But from these 16 numbers, or from these 16 factors, you have to collect the prime factors alone. So 2, 3, 5, 7 are the only prime factors of 210. So the set Q is 2, 3, 5, 7. So the cardinality of Q also seems to be 4. Note that P and Q don't have any similar elements, but their cardinalities are equal, which actually implies P and Q are equivalent. The next set which we are going to discuss is equal set. Two sets are said to be equal if they contain exactly the same elements. That is, when an equivalent set contains the same elements, those are actually equal set. So let's define it in another way too. Consider two set A and B. We say A and B are equal set if every element of A is also an element of B. Take an element from set A, you must also find the same element to be at that set B. Or take any element on B, you must find the same element to be at A. So let's actually get closer to equal set using an example. The set of natural numbers from 1 to 5 and the set of integers where 0 less than x less than 6, which is nothing but the same elements. So these two sets have equal cardinality, also the same element. Any element you take in set A, it is also present in set B. So these two set A and B are said to be equal. Let's actually think something. We just now saw equivalent set and equal set. What is actually common in both? Pause the video, think why is it so. So thank you if you have paused the video and checked it over. I think you are a great brainstormer. Right, so let's see the answer now. If two sets are equal, they have the same cardinality. So they can also be called as equivalent set. Likewise, we saw in the previous example, right? A is nothing but the set of all x belongs to natural numbers such that x ranges from 1 to 5, and the set B is actually the set of integers where the elements of x lie from 0 to 6, removing the endpoints. So these two sets have the same cardinality, so they are actually equivalent set, and also they have the same elements, so they are also called as equal set. But remember, equivalent set cannot be an equal set. We'll just say something which is actually very simple to understand. So every equal set can be called as equivalent set, but not all equivalent sets are equal set. So we'll just again recall what are equivalent and equal set with this example. Consider the set A equals PQRST and B equals x in whole numbers, where x ranges from 4 to 8 including the endpoints, and C is the set of letters in melon and D is the set of letters in lemon. Okay, so we'll describe each set in the roster form, so it makes us easier to find the cardinality and check the elements in any set. So A equals PQRST, which is explicitly given, and B is actually 4, 5, 6, 7, 8. C is MELON, that is the set of all letters in melon, and D is the set of all letters in lemon. So note that all these set A, B, C, D have the same cardinality, that is 5, but A and B are equivalent sets, but C and D are equal set. Since C and D have the same elements L, E, M, O, N, I think you better get this. The next set we'll be discussing is a universal set. So what do you mean by that? A universal set is a set which contains all the elements of the set under consideration, and it is denoted by U. So let's see some of the examples. If we discuss about elements in natural numbers, the universal set U is the set of all natural numbers. For instance, if we take the set A equals the elements of x such that x belongs to natural numbers and x ranges from 1, 2, 3, 4, 5. So the universal set for this set A is actually the set of natural numbers. And if we discuss the set A to be Earth, Mars and Jupiter, then the universal set U will be the planets of solar system. I think this would be clear for a universal set. So let's discuss about disjoint set. Two sets are said to be disjoint whenever there is no elements in common. So let's consider set A to be 20, 22, 23 and 24, and set B equals 25, 30, 40 and 45. We see no common elements in set A and set B, so A and B are actually disjoint set. So to summarize the last two videos which we saw, an empty set is nothing but a set where no elements are present or the cardinality of that set is 0. Singleton set is nothing but a set where only one element is present or cardinality of that set is 1. Finite set is nothing but a set where there is a finite number of elements. Infinite set, a set where there is infinite number of elements. When two or more sets contain the same cardinality, those sets are called equivalent set. Two or more sets which are equal in elements, which are same in elements, is called as equal set. Disjoint set is nothing but two or more sets don't have common elements between them. And universal set is nothing but the set which actually contains all the elements under the consideration. So in the next video, we'll be discussing special types of set which is actually useful in many theories in mathematics. Want to know about that? Stay tuned. This is Max Media with signing off. Bye bye. Take care.